to Lab 1. So the central problem is we are trying to determine what the charge of a piece of tape was after being taped to another piece of tape and then ripped apart. This was done by placing two pieces of tape together and ripping them apart. One piece of tape was then placed between two books, and the other piece of tape was brought near to that piece of tape. The distance at which the bottom tape began to rise towards the top tape was then measured and recorded. This was then used to solve for the charge using GloScript. And the final charge was determined to be 1.3 e to the negative 7 coulombs. So a few key physics ideas that are important to remember here. First, Newton's second law, F equals ma. This was just simply used to calculate the gravitational force. Second, very importantly, Coulomb's law, which is Fe equals the K constant times charge 1 times 2 over r squared, or the magnitude of r squared. This was used to calculate the force between the tape. Equilibrium is also important because due to the lack of motion, the fact that the center of tape was not being acted on by the force when floating, or assumed to not be, the net force must be 0 because there was no motion. System and surroundings. The system is defined as simply the bottom tape, while the earth and the top tape are included in the surroundings, and also the fact that opposite charges attract. Since the tapes attract, we assume they are equal in magnitude and opposite in direction. Here's the code. First, the constants were just found, the K constant and then the G constant, both, this the common constants that we were given, and the length of the tape was found to be 15 centimeters. This was then used to find the mass, as it was 1 gram per meter of tape. This was then converted to kilograms. And D is the distance at which the bottom tape began to raise, and this was 5 centimeters in this case. And here at the calculations, we can see the calculations made. Fg was simply, again, mass times gravity, and the charge was found by setting the Coulomb's equation equal to the gravity equation, and then manipulating the equation to solve for Q. And the square root is included, and because Q1 and Q2 were assumed to be the same, equal and opposite, and so it was simply just Q squared. Here is the resulting equation and simulation. Gravity is found to be 6.53 0.5 newtons, and the charges can be found here. And as can be seen, gravity and the electric force are equal and opposite, evening out. So a few assumptions are made. First, remember that error is negligible. Sorry, it says it there. Each piece of the tape can be treated as a point charge. The mass of the tape is 1 gram per meter, and the charges of each tape have the same magnitude. So a few errors and why some of these assumptions may be incorrect. Touching the tape would have caused uneven charge, so they wouldn't have been the same magnitude, and the charge could have dissipated into the environment. So a few important discussion questions. So if the electrons and protons swap charged, what would happen? So observations would remain unchanged. The tapes were equal and oppositely charged. Flipping the charge might affect which tape was negative, which was positive, but would not affect their relationship and the fact that they would still attract. And why is it important to handle the charge tapes as little as possible? This is important to ensure that the charges remain equal and opposite. If one piece is handled too much, it could lose charge to the hand, making the charge no longer equal and opposite. Thank you.